Good morning, everyone. Welcome to today's hearing. Today we're going to hear from a new witness, Mr. Christopher Mort of Siderise. And I am, as usual, joined by my fellow panel members, Ms. Thuria Istefan and Mr. Ali Akbar. We're now ready to meet today's witness, Mr. Mort. I'm going to check that he can hear me and see me. Good morning, Mr. Mort. Are you there?
Yes, I am.
And you can see me, can you, and hear me?
Yes, I can.
Thank you very much indeed. You should have on the screen in front of you a form of affirmation, which I understand you're willing to make. Have you got it there?
I do.
So can I ask you please to make the affirmation by reading out the words on the screen?
I do solemnly, sincere, and truly declare and affirm that the evidence that I shall give be the truth, the whole truth, and nothing but the truth.
Lovely. Thank you very much indeed. We need to run through a couple of things before you start giving your evidence. Can I ask you first to confirm that you are alone in the room from which you're giving your evidence?
I am.
Thank you. Can you also confirm that you have no documents or other materials with you? Thank you. And finally, can you confirm that your mobile phone is in another room and that you don't have any other electronic equipment with you which is capable of receiving messages?
That's correct.
Lovely, thank you very much. Now, you might like to know that your lawyers are in the virtual hearing room in the sense that they can see and hear everything that's going on. They have the power to intervene if they think it essential to do so, but we have other means of contacting the inquiry's lawyers, and I hope they'll use them. I've asked them to keep their microphones and cameras switched off to avoid any technical difficulties. I hope we shan't have any problems with sound or vision. If we do, I'll ask for a short break while they're ironed out by the technical support team. If you have any problems, obviously just attract my attention and we'll deal with them as best we can. We're going to have a short break roughly halfway through each session. It'll come at round about 11:15 in the morning and round about 3:15 in the afternoon. So those are scheduled breaks, but if you feel at any time you need an additional break, will you just say so and we'll do our best to accommodate you. Now, before we start, is there anything you'd like to raise or to ask me?
No, nothing at all.
Lovely, thank you very much. Well, in that case, I'm going to invite Miss Grange to put some questions to you.
Yes, good morning, Mr. Mort.
Good morning.
Thank you very much for attending today to give your evidence. It is very much appreciated. If you have any difficulty understanding anything that I'm asking you in the course of your evidence, please just ask me to repeat the question or put the point in a different way. And if you need a break at any point, please do say so. Can you also try and keep your voice up so that the transcribers can hear you and take a clear note of your evidence? And that also means not nodding or shaking your head, but giving clear answers to the questions. Now, you've made one witness statement to the inquiry. If we can go to it, it will appear on the screen now. It's a SIL 50298. There's your statement. And if we go on to page 16 within that, we can see there that it's dated the 27th of September, 2018. Is that your signature?
Yes, it is.
And have you read that statement recently?
Yes, I have.
And can you confirm that the contents of it are true and accurate?
Yes, they are.
And have you discussed that statement or the evidence that you're going to give today with anyone before coming here?
No.
Now, let's start with some questions about your background and your experience and qualifications. Now, in terms of your academic qualifications, if we can look at paragraph 6 of your statement on page 2, you tell us there that you've got a higher national certificate in manufacturing, which you obtained in 1997 and 1998. Is that correct?
Yes.
And you've also got a higher national diploma, HND, in fire engineering, which you obtained in 2016. Is that correct?
Yes.
Where did you obtain that qualification from in 2016?
South Wales University.
Yeah. And just in very general terms, what did that qualification entail?
A broad spectrum of fire engineering, from how fires start, occur, through structural analysis, fire engineering, mathematics, etc., etc.
Yes, yes, thank you. And when did you begin studying for that qualification? You say that you obtained it in 2016. How long before that were you actually undertaking that qualification?
It was 3 years prior to that.
Right, yeah. So from 2013 onwards.
Yeah. On a part-time basis.
On a part-time, yes. Fitting it in with your day job, yes?
Correct.
Yeah. Now, if we go back to page 1, paragraph 4 of your witness statement, you tell us that you started in the facade industry in 1998, working for Denver Aluminium Limited. Is that correct?
That's correct.
And what was your role there at Denver Aluminium Limited?
I was a facade designer.
Facade designer?
Yeah.
Yes. And then in 2000, you moved to Vision Aluminium Limited as a facade design manager. Is that correct?
That's correct.
And were you involved in any fire testing in those roles when you were the facade design manager?
At Denver, no. When I worked for Vision Aluminium, I was trained at Schuko Facades as being able to design their fire facade system, which was a curtain wall system.
Right, yeah. And how do you spell the you said Schuko Facades? That training.
Yes, SCHUCO.
Yeah, thank you. And then in 2002, you joined Siderise as the product manager and marketing manager for the technical and commercial departments. Is that correct?
Yes.
Can you explain what that role involved, that product manager and marketing manager for the technical and commercial departments?
It was basically looking after the Siderise customer base.
Yeah. And what was that Siderise customer base?
Predominantly curtain walling, facade companies, other building envelope companies, architects, consultants.
Yeah, thank you. And is it right that you remained in that role at Siderise until 2007 when you went to work for Hilti?
That's correct.
And what role did you have at Hilti?
Building facade specialist, basically the same role as I had with Siderise. Hilti had formed a division, which I joined.
Yeah. And you stayed at Hilti until you then rejoined Siderise as their sales and technical engineer 2 years later in 2009. Is that correct?
That's correct.
Yeah. And then 2 years after that, in 2011, you took on the role of technical officer for fire within Siderise. Is that right?
That's right.
Yeah. So just to surmise, would it be fair to say you've got around 20 years experience working in the facade industry, either as a facade manager, designer, through to being a technical officer?
Yes.
And is it right that you were also employed by Alcoa for just under 7 years between 1991 and 1998? Is that right?
That's correct.
What was your role at Alcoa?
First joined as a tool maker in the tool room, and then progressed through to the design office.
And what kind of design work were you involved in at Alcoa?
Designing aluminium extrusions.
Right, yes. And then if we look at paragraph 6 of your witness statement now on page 2, if we could have that back up, you tell us that you sit on various industry committees. So we looked at the first part of that, and then in the second line, you begin to tell us what these committees are. So just going through them, you sit on the Association for Specialist Fire Protection, known as the ASPF, yes?
Yeah, the ASFP, yes.
Sorry, ASFP. And you also sit on the British Standards Institution Standards Development Committee for non-load bearing separating elements, yes?
Yes.
That committee is called the FSH/22, is that correct?
Yes, 22/7.
Yeah, 22/7, sorry. And you also sit on a European Committee for Standardisation, and you tell us that you sit on the Committee for Cavity Barriers known as TG9 and the Committee for Facades known as TG8 on behalf of the BSI, is that correct?
That's correct.
And is it right that you're also an affiliate member of the Institution of Fire Engineers?
Yes.
And then at paragraph 7 below that on the screen in front of us, you tell us what your role as technical officer for fire at Siderise has involved, and you describe that role as including product development, arranging and attending testing, including testing relating to fire, thermal or acoustics, and also dealing with customers. You say you get involved if a question or issue requires specific technical input. Are you still in that role as technical officer for fire at Siderise?
The role has evolved. I'm now technical development director for Siderise.
Technical development director. When did you take up that appointment?
Last January.
Yeah.
Down in 2020.
And can you help us, and we'll look at it in more detail later, but did you write or assist in writing any of the marketing literature or installation guidance that Siderise published for its cavity barriers?
I would have technically reviewed the documents.
Yeah, so you do a technical review of those documents.
Correct.
Great. Now, just some questions about previous cladding fires. At the time that you were involved in the Grenfell Tower project, that was in 2015, and again, we'll come and look at your involvement in the Grenfell project later. At that time, were you aware that there was a long history of external cladding facade fires on high-rise residential buildings, both in the UK and internationally abroad?
I was aware of some UK fires that led to the authoring of BR 135 and the development of 8414.
Yes.
I was also aware of some fires overseas.
Yes. Which domestic fires were you aware of that led to BR 135?
There was one in Scotland, in Stirling. From the top of my head, I can't remember the specific.
Yeah, is that the Garnett Court fire in Irving? Yes.
Yes.
Had you heard of the Lacanau House fire in Southwark in London in 2009?
Yes, I had.
Yeah. And in terms of the fires that you were aware of internationally, can you help us? What fires were you aware of at that time?
Just what came on news media. Specific dates, can't recollect, but fired maybe in Turkey, some in Dubai. But these were of what seemed to be flammable cladding.
Right, I see. That was your understanding, was it? That was,
yes.
It was flammable cladding that had contributed to those fires?
Yes.
So do I take it that you were aware of a spate of fires in high-rise buildings in the UAE? Were you aware of those as early as 2012, 2013, or would it be more like 2015 that you became aware of those?
I can't really recollect.
Okay. Did those cladding fires ever cause you or anyone else within Siderise to reflect and to question the way in which it was marketing and promoting its cavity barriers?
No.
Now, when carrying out your role, did you have some familiarity with the building regulations and the associated practical guidance in approved document B on fire?
Yes.
And when undertaking your role as technical officer within Siderise, were you familiar with the guidance in approved document B about the performance and location of cavity barriers?
Yes.
And were you familiar with the guidance about the B3 Part 4 functional requirement on internal fire and smoke spread in concealed spaces?
Yes.
And the guidance in section 9 of ADB?
Yes.
And were you also aware of the guidance about the B4 functional requirement on external fire spread in section 12 of ADB?
Yes.
Were you aware that the guidance in section 9 of approved document B required at paragraph 9.3 that cavity barriers should be provided to close the edge of cavities, including around openings?
Yes.
And that guidance was also clear in diagram 33, wasn't it, of
Yes.
ADB? Let's just have a look at that, just to remind everyone of that diagram. If we go to CLG 50224 at page 82, here we have diagram 33 that appears in section 9 of approved document B, dealing with effectively compartmentation. And we can see that there's various shaded parts on this diagram, including some green, which indicates fire stopping, and some grey shading, which indicates cavity barriers. So can I take it that you were familiar with this guidance when you were technical officer for Siderise from 2011 onwards?
Yes.
And we can see that under the key to the diagram, where it says cavity barrier at the bottom, it's got reference there to table A1, item 15 in approved document B. And I just want to go to that table now. It's at page 124 of ADB, if we could go on to that. So this is table A1. We can see it's in the title of it in green at the top. Specific provisions of test for fire resistance of elements of structure, etc. And again, can I take it that you were familiar with this table at the time you were technical officer?
Yes.
And effectively what we see is various different parts of the building. And in this table, it tells you what the fire resistance elements need to be for those parts of the structure. That's correct, isn't it?
Yes, it is.
And if we go over the page, we can see on the next page, just note at the top, we can see it says part of building, and then we can see the heading minimum provisions when tested to the relevant part of BS 476. And there's a little footnote, which we'll come back to. And it also makes clear in brackets that the figures we're seeing here are minutes. That's correct, isn't it?
Yes, it is.
And then if we go down to item 15 in this list, we get the reference that we saw earlier in diagram 33, taking you to cavity barriers. And we can see that there it's saying, it's clear if we can see the top of the page as well, that cavity barriers need to have 30 minutes integrity and 15 minutes insulation. That's correct, isn't it?
Yes, it is.
Yes, thank you. So you can see the load-bearing capacity column isn't applicable because cavity barriers are not load-bearing, are they?
No, they're not.
And so the requirements of ADB were 30 minutes integrity, 15 minutes insulation. And then that footnote at the top, which relates to the part of BS 476 that's applicable, if we go down to that footnote 1 at the bottom of this page, we can see in the notes there, number 1, what it does is it tells you which parts of BS 476 may be applicable. You've got part 21 for load-bearing elements, part 22 for non-load-bearing elements, 23 for fire protecting suspended ceilings, and 24 for ventilation ducts. Do you see that there?
Yes, I do.
Now it's right, isn't it, that BS 476 part 20 is the general British standard, which sits with those ones listed there. And that contains general principles relating to the method of determining the fire resistance of elements of construction.
Yes, part 20 is the parent test document, and then these are supplementary standards for testing supplementary elements.
Yes, thank you. Yes.
They refer back to part 20.
Yes, thank you. That's very helpful. Now, what was your understanding when considering this table about which part of BS 476 in this series that we see at note 1 was relevant to the testing of cavity barriers?
From 21, 22, 23, or 24 needed, none of those are applicable.
None.
Because 21 is for load-bearing elements, part 22 for non-load bearing elements, but within the scope, it's for testing roller shutters, partitions, etc. There is no mention of cavity barriers in there. So when in discussion with a UCAS accredited test laboratory, they test using the principles of part 20. Now the failure criteria in 21, 22, 23, 24, in terms of integrity and insulation, are uniform. They're the same.
A uniform, yes,
Yeah.
I understand. Yes, thank you, that's helpful. And we're going to come on and discuss this in more detail, but just to summarize, what you're telling us there is that although it refers to the relevant part of 476 in the table, in fact, for cavity barriers, none of those parts actually refer to the testing of cavity barriers, do they?
No, that's correct.
So I think what you're telling us, and we'll come on to this, is that for cavity barriers, testing has been done to the general principles contained in part 20. Is that correct?
That's correct.
Part 22 for non-load bearing elements, would there be any aspects of that which you would consider relevant to the testing of cavity barriers?
Not particularly, because it's dealing with roller shutters and partitions. When I mean partitions, we mean partition walls rather than small elements. The pass failure criteria in part 22 is referred back to part 20 for the insulation and integrity. It's the same within the EN suite of test standards. They refer back to the parent EN 1363 part 1.
Yes.
So,
yes, and we'll come on to see in some of the test reports the way in which the principles in the tests you just explained have been used in the testing of cavity barriers, yes?
yes.
Yeah. Now, just to help the panel and anyone else watching, I just want us to be very clear what is meant by integrity and insulation, as we saw in that table. Is it right that integrity, in crude terms, is the ability to contain fire and stop flames and hot gases from physically passing the material in question?
That's correct.
A more technical definition, which we see in BS 476 part 20, would be the ability of a specimen of a separating element to contain a fire to specified criteria for collapse, freedom from holds, cracks and fissures, and sustaining flaming on the unexposed face. Do you agree with that?
Yes.
Yes. And then in contrast, where we talk about insulation, in crude terms, that's about the thermal transmittance of heat, isn't it? And the material's ability to prevent the passage of radiant heat.
Yes.
And in technical terms, it's described in BS 476 part 20 as the ability of a specimen of a separating element to restrict the temperature rise of the unexposed face to below specified levels. Again, can we agree on that?
Yes, we can.
Yeah. And just for completeness, in terms of definitions, if we can go back to ADB again and have the last document up on the page, that's CLG 50224. I now want to just look briefly at page 143. This is Appendix E of approved document B, where we see some definitions. And I just wanted to draw attention to, at the bottom of that first column, can you see there's a definition there of cavity barrier?
Yes.
And it says a construction other than a smoke curtain provided to close a concealed space against penetration of smoke or flame. And then if we go up to the top, or provided to restrict the movement of smoke or flame within such a space. Do you see that?
Yes.
And again, were you familiar with that definition while
Yes.
you were technical officer?
Yes, it was.
Now, I'm going to ask you in detail in the next section of my questioning about the testing which Siderise carried out on its open state horizontal cavity barriers, those with an intumescent strip. But before we do that, I just want to remind the panel and the listeners exactly what these barriers are. If we can go to Dr. Lane's phase 1 report, this is BLAS 608, page 42. And here we have two helpful figures. We can see at the top at figure 8.45, this is one of the horizontal intumescent cavity barriers as installed at Grenfell Tower, yes?
Yes, looking at the picture, yes.
Yes. And we can see an extract from Siderise's product literature just below that in figure 8.46. And again, that is an open state horizontal cavity barrier, yes?
Yes, it is.
And I just want to be absolutely clear what these are. So you can see it from the label in the top picture. It states there in the label, black weather-resistant polymer film encapsulating leading edge, continuous high-performance intumescent strip installed behind this film. So is it right that at that leading edge, what you get with these barriers is a high-performance intumescent strip, yes?
Yes, it is.
And the purpose of that strip, is this right, is that upon heating, that strip expands to fill a gap that has otherwise been left within the cladding system?
Yes, it does.
And indeed, you can see that gap perhaps more clearly in the product literature below, where you can see that gap just sits back from what might be the face of where the cladding panel would go. And these are to be contrasted, aren't they, with what are known as full fill cavity barriers, which are blocks of material that simply fill the whole space, yes?
That's correct.
Yeah. And so just going back to these horizontal cavity barriers, can you just explain in your own words how these are intended to work?
They are there installed with a nominal air gap to meet the functionality of the normal use of a rain screen system, where the back of the rain screen has to be drained and ventilated. Then, should there be a requirement for it to be a sealed, full seal, then at between 125 to 130 degrees, the intumescent exfoliates, expands across the gap to seal the gap, to prevent the passage of fire to the higher levels for the duration of 30 minutes. That is providing that the external panel remains in place.
Yes, and again, I think we'll come on to this, that last sentence there that you just stated, you said that is providing that the external panel remains in place. It's vitally important, isn't it, in terms of how these panels operate, that there is an external face for them to butt up against if they're to operate properly.
That's the fundamental principles of all fire stopping, not just cavity barriers, that the substrate in which they're installed has to remain for the same duration of the fire period as the fire stop or the cavity barrier.
Yeah, yeah. Now, so as I've said, I'm going to focus a lot of my questioning this morning on the testing of these open state cavity barriers, these intumescent cavity barriers. At this point, can we just look at Mr. Swales's witness statement to the inquiry? This is at SIL 50306. Now, is it right, can you just confirm that Mr. Swales is the Chief Commercial Officer at Siderise, yes?
Yes, that's correct.
And this is his witness statement to the inquiry. And he tells us in this statement that he's been Chief Commercial Officer at Siderise since 2013. For the transcript, that's at paragraph 5 on page 2. I want to look first with you at page 11, paragraph 44. So he says, prior to 2006, Siderise's cavity barriers were verified by the Loss Prevention Council. We'll come back to that in a moment. And he says the use of rain screen was still relatively uncommon in the early 90s. Consequently, the demand for dedicated cavity barrier products was infrequent stroke negligible. Due to the paradox of cavity barriers needing to be installed with an air gap to maintain ventilation versus the integrity criterion required for compartmentation, the advice at the time from the Loss Prevention Council was that it was not possible to satisfy both requirements. And then he says, from the mid-90s, we received more inquiries for this type of application. And he says, as such, in July 1997, I requested that the LPC, the Loss Prevention Council, confirm their position. And then he refers to a document, which I'll take you to in a moment. This was used to support the use of an ad hoc assembly with standard cavity barriers fitted to leave a 25mm gap. From this time to 2002, from recall, there were a small number of projects, literally one or two, where we supplied product for a, quotes, rain screen application. And then he goes on, in March 2002, we prepared a data sheet which illustrated standard CW curtain wall product with an integral intumescent material, and he attaches that data sheet. And then if we go on and read from 45, he says also from approximately 2002, in this early product development phase, we evaluated a number of different intumescent materials through ad hoc material testing. Now, just pausing there, is it right that from around 2002 onwards, when you first joined Siderise, the company was beginning to develop open state cavity barriers for use in rain screen applications?
Yes.
And based on your own involvement in the industry in the mid-90s, were you aware of a growing demand for such a product?
In the mid-90s, I was involved with predominantly curtain walling. We didn't.
Right.
The companies I worked for, we were curtain wall specialists, not rain screen specialists.
I see. So approximately when did you start to become aware that there was a growing demand for open state cavity barriers in the market?
When I joined Siderise.
Were you aware, after you joined Siderise, that Siderise had sought advice from the LPC, the Loss Prevention Council, about these open state cavity barriers?
Yes, I was.
We're going to go to that letter from the LPC in a moment. But just before we do that, we saw in the first sentence of paragraph 45 that Mr. Swales was referring to ad hoc material testing of different intumescent materials. Can you help us? What, if any, involvement did you have in such ad hoc testing of those intumescent materials?
Very little in the very early days. It was more 2006 onwards, I was more involved with testing.
Right. So do you know much about what that ad hoc testing was of different intumescent materials?
Not in the very early development phase.
Okay. Now, if we go back to Mr. Swales' witness statement on the page that we were on, looking at paragraph 45 on page 11. In the second sentence of paragraph 45, he says, we formally redeveloped the product in 2006 via an NPDI, New Product Development Introduction Project. And he goes on to say that there was a concept approval meeting on the 1st of July 2006. Can we just look at the agenda for that concept approval meeting? It's a SIL 402586. Now we can see there the heading and the date, 1st of July 2006 on the right-hand side. And we can see that the meeting was called by you, and you appear to be the note taker as well, yes?
Yes.
And the attendees included, well, it says Steve Bond, Technical Director, and Chris Mort, Technical Manager. Was it just the two of you at this meeting?
Yes, it was.
And we can see from the agenda items below, agenda topics, that you were responsible. We can see the initials CM. You're responsible for application description. That's the second one down. And then in the fourth one down, we can see statutory requirements. Sorry, statutory regulatory requirements has also got your initial next to it. Is that correct?
Yes, it does.
So were you responsible for the statutory and regulatory requirements around this new product development?
Yes.
And then if we turn to page 2, we can see that under there's a heading there, agenda topics, and we can see the first part underneath that, there's a heading product concept name, and then there's various notes under the discussion, so that these appear to be minutes of the meeting. Now the rest of these minutes appear then in a different document. If we turn to SIL 402587, would you agree these appear to be a continuation of the minutes of that meeting?
Yes, they do.
Yeah, thank you. Yeah, and just to be clear, the agenda items match up completely. And if we look at the heading at the bottom of that page, we can see the heading statutory regulatory requirements with your initial next to it. And under discussion, it reads, product to meet with the requirements of a modified BS 476 Part 20 test. And as a result of a positive test, compliance with approved document B 2000 edition, incorporating the 2000 and 2002 amendments, in particular, sections 9 compartmentation and 10 concealed spaces, cavities. So that's what we see under the discussion. And as we've already discussed, BS 476 Part 20, you described it very well as the parent of the fire resistant testing, yes? Setting out general principles.
Yes.
And can we agree that it describes a procedure for laboratory testing for the determination of fire resistance of elements of construction, including failure criteria for integrity and insulation?
Yes, it does.
So looking back to the minutes of this meeting, can you explain precisely how you were going to modify that British standard when going about this testing?
We wouldn't modify the actual standard because as a company, you can't modify a standard. The test procedure has a requirement for integrity that you have gap gauges, and should a gap gauge be able to be applied to a specimen prior to the start of a test, then technically the test shouldn't be started.
Yes, now just pausing there, you talk about gap gauges, and we'll come to that in the documents in a moment. Is a gap gauge effectively a metal rod that is inserted into the specimen, and if it gets through gaps, that's a failure?
Yes.
Yes, thank you. Sorry, carry on. What I'd like to understand is how were you going to modify the requirements of that test to test the intumescent open state cavity barriers?
It was a discussion between ourselves and Warrington Fire, UCAS accredited laboratory, on how you can conduct the test for an open state cavity barrier that's been demanded by the market of brain screens, and still be able to perform the test on a furnace. And we came to an agreement that whilst the integrity technically fails before you start the test, that they would record and monitor the closure of the intumescent to reinstate the integrity value of the product.
Yes, I understand. And again, we're going to come on to the testing that Warrington Fire did of these products for Siderise. But I think, so what you're explaining is that they agreed to take data following the closure of the cavity by the intumescent, yes?
Yeah, when you start the test, the recording starts from time 0. So they record all the data from time 0.
Yes.
So they could monitor the thermocouple is actually attached to the cavity barrier itself.
Yeah. So just looking back to the minutes though, can you explain with that form of testing how you were going to modify the requirements of BS 476 Part 20?
Like I said, we did not modify the requirements of BS 476 Part 20. We had open discussions with the UCAS accredited laboratory of how we could use the principles of BS 476 in order to test a cavity barrier that was being requested by the market at the time. And we were fully aware that the integrity criterion was not met at the start of the test.
Yes. So thinking back to these minutes, what principles of 476 testing did you think could be transposed into the testing of these cavity barriers?
All elements except for the gap gauge at the very start. Gap gauges, cotton pads for measuring of integrity could be introduced after the start of the test. No issues. This is not uncommon across fire resistance testing. There are fire tests of other elements that, like dampers, that need to activate and react to temperature, that the integrity criterion, whilst there for the duration of the test, in the first 5 minutes, the laboratory have got the responsibility to establish a controlled furnace environment in terms of temperature and pressure. So in the first 5 minutes of a test, that is the fundamental principle of the test standard, and that allows for intumescence to react. It allows for intumescence around doors to react. It allows window, when they test windows for intumescence, for that to react, dampers to activate. So it's not an uncommon principle.
Okay. Just going back to the minutes, we could have the minute back up on the page that we were just looking at. Yes, thank you. We can see that it's referring there. So it says product to meet with the requirements of a modified BS 476 Part 20 test. And then it says, and as a result of a positive test, compliance with approved document B, and then it refers to various parts. Why was it considered that that testing to some of the requirements of 476 Part 20, but not all of them, would satisfy ADB? Can you explain that?
It would be proof of performance for both integrity and insulation to meet the 3015 requirement once the intumescent is activated.
I see. But what had led you to the conclusion that testing in that manner could be satisfactory evidence of compliance with approved document B and the building regulations functional requirements?
There have been various discussions with other bodies within the industry, CWCT for one, on how, as a manufacturer of passive fire protection, could we meet the demands of cavity barriers within rain screens. And this was a way of proving the performance as previously assessed by the LPC in the LPC assessment document.
Right, I see. Well, we'll come back to some of that in a moment, because we're going to look at what the CWCT said a little later. Staying with this document, can we turn to page 3 of it now? There's a heading in the middle of that page, project assigned an owner. And it says underneath, as the project is a fire product, then the best owner would be Chris to be project owner. So can you explain, why were you the most appropriate person in 2006 to take on this fire product ownership?
Because I was involved in fire testing. I was in testing other products for the business.
Right. What other products were you involved in testing?
Standard CW type products.
Do you mean standard curtain walling type
Yes.
products when you refer to CW?
Yes.
Yeah. I see. So you had some experience of testing with curtain walling products. So that's why you were considered to be the appropriate person to take on this new product planning. Yes.
That's correct.
Yeah. And we can see under action items just below that in the same box, it says Chris to complete the new product information planning and review sheet for this product. Yes.
Yes.
And then the minutes conclude under project approved and accepted for development. Under conclusions, so it's the second heading down in that last bigger box. It says this: all business and ethical requirements are met by this proposed product, therefore this is approved for development. Can you help us? What does that mean?
It meets with the compliance. It meets with what Siderise strive to do, is offer fully tested products to the market.
I see. And specifically when there's reference there to meets all ethical requirements, what ethical requirements were considered at that stage?
I can't recollect.
Let's turn now to the Loss Prevention Council letter that Mr. Swales referred to in his witness statement. This is a SIL 50285. So this is a letter dated 29th of July 1997 that was sent to Mr. Swales. And if we just look, sorry, if we could just see back at the bottom, the author of the letter is somebody called R.H. Earle, who's a senior consultant at the Loss Prevention Council. And I just want to read the first paragraph at this stage. So the author says, the cavity between curtain walls and fire compartment walls, floors, need to be sealed within a cavity barrier to the same fire rating as the compartment wall or floor. In the National Building Regulations, the exact requirements for these cavity barriers is ambiguous, and no mention is made of movement between the curtain wall and the compartment wall or floor in a fire situation. In the Loss Prevention Council design guide for the fire protection of buildings, it is assumed that the cavity barrier will take up any movement between the elements of construction. Then it says this: a particular problem is rain screens, where the cavity barrier cannot fill the full width of the cavity, as the rain screen requires a typical 25mm space to carry out its function. Where rain screens are fitted, it is our understanding that the fire brigade assume that the cavity barriers between the rain screens and the compartment floors are ineffective, and that therefore up to 4 floors could be involved in a fire before it is brought under control. Now, just pausing there, when it states there that the rain screen requires a typical 25mm space to carry out its function, is that because in some rain screen systems, it would need to be able to allow the drainage of water behind it and to provide ventilation to the system?
That's correct.
Now, as to that information about how the fire brigade viewed cavity barriers and their effectiveness in a rain screen system, can you help us? To what extent was that taken on board by Siderise when developing its products?
That's why we were looking to test the cavity barriers to prove their performance.
I see. So at the time this letter was written, is it your understanding that there was this general concern that cavity barriers would be ineffective in rain screens?
At the time when this letter was written, I wasn't part of Siderise.
I understand. But did you become aware of this letter when you began working at Siderise?
Yes, I did.
And did you read it and take on board what it was saying?
To a point, yes.
When you say to a point, what do you mean by that?
It's further down the letter where it confirms that the cavity barrier would restrict the movement of smoke or hot gases as much as practical.
Yes, we'll come to that second paragraph. Sorry, we'll come to that second paragraph in a moment. Just sticking with that, the end part of that first paragraph, where rain screens are fitted, it's our understanding that the fire brigade assume that the cavity barriers between the rain screens and the compartment floors are ineffective, and that therefore up to 4 floors could be involved in a fire before it's brought under your control. Was that your understanding when you first began working for Siderise, that that was the fire brigade's assumption about cavity barriers in rain screen systems?
I don't recollect making any specific attention to that.
I see. To what extent can you help us as to whether that statement there and that assumption by the fire brigade was taken into account in terms of the way Siderise promoted and marketed its products for rain screen systems? I
can't from the date of that letter, no.
And then, as you've said, the letter goes on in the second paragraph. It starts by saying we've looked at the Dane Architectural Systems Limited drawings, and it gives the numbers of the drawings for the contract at Wellesley Road, Croydon. We confirm that your MS cavity barrier system is suitable for this application for sealing the cavities between the curtain walling and compartment floors and the columns compartment walls. And then it says this: where the rain screens are fitted, a 25mm wide gap must be left between the outer edge of the cavity barriers and the rain screen so that the rain screen can fulfill its function. Although the cavity barrier will not seal the cavity at the rain screens, it will restrict the movement of smoke and hot gases as much as is practical. Do you see that?
Yes.
So are you saying that Siderise relied on that opinion by the Loss Prevention Council when it was developing its open state cavity barriers?
Yes.
So they're saying there, can we agree that it's going to restrict the movement of smoke and hot gases as much as is practical? But that's all, isn't it?
Yes, it is.
And did you ever consider how this new product that you were developing would address those concerns as expressed in the letter?
From 2006 onwards, when I was involved with the testing and I pushed the laboratories to test the products, then yes.
Yeah, you say there, and I pushed the laboratories to test the products. We'll come to this in a moment, but is it right that the laboratories were somewhat reluctant to engage in this testing at first?
The reluctance was based on the health and safety of conducting the test within a laboratory. It wasn't a reluctance to test the product, but it was they needed to justify how they could start a furnace that rises to 600 degrees in the first 5 minutes with a 25mm open gap.
Right.
So there was a clear understanding between us and Warrington Fire that the test would run. If there was any issues that would cause any health and safety issues to the laboratory, they would stop the test immediately through the emergency stop procedure. That is the only reluctance. There was a clear synergy, if you will, between ourselves and the test laboratories and others to try and get this sort of product tested, because there was more demand coming from the market for this type of product.
Yeah. You've mentioned quite a few times now that demand coming from the market. In reality, is that what was driving this, that there was a demand for an open state cavity barrier? So you needed to go and do some testing to try and show that that was a safe product to be using?
Correct. If you were to use full fill cavity barriers, they were rejected on the fact that they trapped water and could cause other issues for a rain screen. Rather than it was expected that the passive fire protection industry would come up with a way of allowing the ventilation and drainage of the system. So Siderise weren't alone in developing products for the market at the longest time.
I see. And where it says it was expected that the passive fire protection industry would come up with a way of allowing the ventilation and drainage of the system, who was placing that expectation upon you?
It was coming directly from the facade industry, and other guidance out there, the likes of CWCT, where a lot of rain screen systems are drained and ventilated, as we've already discussed, through the back face of the system. There's a requirement to keep the insulation in the back face dry. The insulation is keeping the building warm. That needs to be kept dry. There can't be any capillary action going back to the structure, which could allow for damp on the inside of the building, etc., etc.
I see. Yes, thank you. Now, just sticking with this new product information planning, if we can turn to a document SIL 408401. This is a NPI, New Product Information Planning and Review sheet, dated the 15th of July 2006. Now, do you remember completing this document?
Yes, I do.
And
if we look at the project owner, it had changed to Peter Batchelor.
Yeah.
This was finished when I had left the business.
I see. So you began this and then he
Yes.
finished it off?
Yeah.
When you moved to Hilti, yes?
Correct.
Yeah. And then we can see identical wording on the left-hand side, third box down, under statutory regulatory requirements, product to meet with the requirements of a modified BS 476 Part 20 test. And as a result of a positive test, compliant with approved document B 2000 edition, and then it refers to particular parts of that. Had you done any further investigation between the concept approval meeting and completing this planning and review document as to the suitability of doing some modified BS 476 Part 20 testing?
There was discussions between ourselves and Mort and Fire on how we could test a cavity barrier with an intumescent with a 25mm cap. So yes.
Yeah. And can you help us, who were you having those discussions with at Warrington Fire?
It would have been with Chris Johnson at the time.
Yeah. I see. So you'd been having some discussions with Warrington Fire about how you could use parts of the BS 476 Part 20 test principles in a test of these intumescent cavity barriers.
Yes.
Yeah. And if we just look at this point at your witness statement, paragraph 38, page 10 of your statement. I think we probably already covered this, but you state, we can see 4 lines down, there's a line on the right beginning, testing to BS 476 Part 20. You say this, testing to BS 476 Part 20 has been established for many years, though it was recognised as not being ideal, as the standard cannot be applied directly to open state cavity barriers. And that's for the reason that we've already discussed, is it, that under Part 20 of 476, these open state cavity barriers would automatically fail certain requirements?
Yes, it's the gap gauge issue. The intumescents react on a furnace test very, very quickly within 10 to 20 seconds of ignition of the furnace. So it's that initial, before you start the furnace, you have an open gap.
Right,
So technically, you shouldn't start the furnace with an open gap
right.
because of the health and safety condition requirements.
Yes, I see. Yeah, and we're going to come on to look at some of the test reports in a moment to see what data you were getting from that. Mr. Swales says in his witness statement, we don't need to go to it, but for the transcript, that's at paragraph 39, that to his knowledge, Siderise were the first in the industry to test open state cavity barriers. Is that your understanding as well?
Yes.
So when you were doing this, there was no precedent for testing open state cavity barriers when you were embarking on this project?
Not that I was aware of.
And then just looking back at paragraph 38 of your statement, you go on in that paragraph after the part that we read to explain that the integrity condition in paragraph 10.3 of BS 476 part 20. Now that's the part that requires this gap gauge test, yes?
Correct.
Cannot be complied with until the intermescent closes the opening. The gap gauge required by 10.3.2b could pass through the opening, which is an automatic fail until the intermescent closes. In other words, any open state cavity barrier would be subject to an automatic failure at the start of the test. Accordingly, testing to the principles of 476 part 20 or ad hoc testing to 476 part 20 is usually referred to in reports. Now, can you help us? I appreciate you were talking to Warrington Fire about this ad hoc type of testing. Did you ever check that approach with anybody else in the industry?
I can't particularly recollect any specific discussions.
Did you ever, or can you recollect ever having any discussions with anybody within government or anybody who was responsible for approved document B about how satisfactory it would be to test in this ad hoc way?
No.
So does it follow that you were reliant on the advice you were getting from Exova in testing in this way?
That's correct.
Yes, thank you. And if we can look back now at Mr. Swales's witness statement, paragraph 46 on page 12. He tells us there in the first lines, he says, the demand for rain screen cavity barrier products slowly increased to the point that in 2005, 2006, we initiated discussions with Bodycoat, Warrington Fire, Exova to undertake product testing. Now, were you personally involved in those discussions?
Yes, I was.
And he goes on, he says, picking it up in the third line, it took a lot of discussion with Exova to undertake the test, as they were nervous that they could safely permit the testing of an open assembly. And then he goes on, there was no precedent to this test and it was considered ad hoc. And then you go on, and we're going to look at some of these test reports in a moment. So just going back, we had a discussion about whether or not Exova were reluctant. Was the only reason they were nervous and reluctant about the health and safety aspects of performing this test? Or were they also reluctant because they were concerned that they might be opening the door to some kind of compliance test for open state cavity barriers that they didn't feel comfortable with?
No, it was purely down to a health and safety requirement.
Did they ever express any concerns about whether it was appropriate to be testing in this ad hoc way using principles of 476 part 20?
It's common to test to use part 20 or EN 1363 part 1 for a test that doesn't fall into one of the other prescribed test standards. So it's common.
Yes, I understand that's your evidence, but my question was, did they ever, so this is Exova, did they ever express any concerns about whether it was appropriate to be testing in this ad hoc way using the principles of 476 part 20?
None at all.
So they were entirely comfortable to go ahead with this testing, apart from the health and safety aspects?
That's correct.
Well, did anyone from Exova ever express any concern that they didn't want to be seen to be endorsing the safety of open state cavity barriers in circumstances where there was no accepted test for such a product?
No.
Now, in a moment, we're going to come to look at a number of the test and assessment reports which were produced for these open state intumescent horizontal cavity barriers by Exova and later by some others. But before we do that, I want to put a number of propositions to you to see what we can agree at this stage. Can we agree this, that prior to Siderise manufacturing and supplying open state horizontal cavity barriers for use on Grenfell Tower, those products had only ever been tested for insulation and integrity between two concrete lintels or concrete blocks?
We are looking at here testing an element of material. When you're dealing with fire resistance tests, to get a fire resistance level of any form of passive fire protection, the general principles are to test them between two elements of concrete, because the results are only applicable for that barrier in isolation. It is then for further fire engineering, for fire engineers to take the test results of all the construction elements on a build-up, so any walls, floors, facades, etc., to make their judgment for the building, because every manufacturer should have the fire resistance or reaction to fire properties of their products they are selling.
Yes, thank you. Is the answer to my question yes, that prior to Siderise manufacturing and supplying open state horizontal cavity barriers for use on Grenfell Tower, those products had only ever been tested for insulation and integrity between two concrete blocks?
As per the standard, yes.
Thank you. And it follows from that, again, can we agree this, that prior to supplying the horizontal open state cavity barriers for the Grenfell project, those products had never been tested for insulation and integrity in a rain screen system where the outer cladding was ACM, aluminium composite material?
There is no available test standard in which to test what you have just described, other than an 8414 test that does not test the performance of the cavity barrier, test the performance of the system.
I understand that's your answer, but again, is the simple answer yes, that prior to supplying the horizontal open state cavity barriers for the Grenfell project, those products had never been tested for insulation and integrity in a rain screen system where the outer cladding was ACM?
That is correct, but then there are no available test standards, as you described, there to be able to test for fire resistance.
Yes, I understand. And can we also agree this, that prior to being manufactured and supplied at Grenfell Tower, neither the horizontal nor the vertical cavity barriers had been tested in void sizes as large as those for which they were used at Grenfell Tower? Can we agree that?
Yes.
And extended application assessments and tests for those larger void sizes were only carried out after the Grenfell fire?
Yes.
Thank you. Now we're going to look at 4 Exova reports from 2007, 2009, 2010 and 2011 to see what testing and assessments were in fact done at Exova, or Warrington Fire as they then were, during that period. So this is 2007 to 2011. If we can go to the first of those reports, if we can turn up SIL 50290. So this we can see is the first test report. It's dated the 1st of February 2007. We can see that on the bottom right-hand side. And then if we go back to the top, we can see that the title is Fire Resistance Test Utilizing the General Principles of BS 476 Part 20, 1987, on 2 specimens of floor-mounted and 2 specimens of wall-mounted cavity barriers. And then if we turn to page 7 of this report, we can see who was present. And we can see in the middle of that page under instruction to test, it says the test was conducted on the 3rd of October 2006 at the request of Siderise. And then below that, it tells us that the test was witnessed by Mr. C. Mort and Mr. S. Swales. So you were present at these tests, yes?
Yes, it was.
And if we can turn back to page 3, and there's a section summary of the tested specimens. Here it's explaining what was being tested in these tests. If we look at the 4th paragraph down, it tells us that specimens C and D, reference Lamatherm CWRS, comprised a mineral fibre based insulation with polyethylene fibre reinforced aluminium foil facings, and had overall dimensions of 225 millimeters wide, 1000 millimeters long, and 75 millimeters thick. And then it said specimen C, complete with a graphite based intumescent strip retained to one edge of the primary seal by folded returns of support brackets that penetrated the full width of the specimen, and specimen D, complete with a palisol based intumescent sheet retained to one edge of the primary seal. So in this description, it's right, isn't it, that it was specimen C and D that were the open state cavity barriers with intumescent strips, yes?
Yes, that's correct.
And that's in contrast to specimens A and B, just to note above that, in the paragraph immediately above, they were directly bonded to the damp-proof course and friction fitted, yes?
Yes.
And we can see, I read out the dimensions of the intumescent cavity barriers in that 4th paragraph, 225 meters wide, 1000 millimeters long, 75 millimeters thick. And we can see in paragraph 2 of that section, looking back up, it says the sections of wall and floor were formed from precast reinforced aerated concrete lintels and had overall dimensions of, and then it gives the dimensions. So this is telling us that the cavity barriers were tested in wall and floor sections which were formed of precast reinforced aerated concrete lintels. That's correct, isn't it?
Yes, it is.
And those had apertures or gaps of 250 millimeters. Is that right?
Yes.
Yeah. So effectively, you've got concrete with rectangular gaps in them that you're testing these barriers in, yes?
That's correct.
And if we look at page 4 of the table, sorry, page 4 of this document, we can see a results table. We could blow that up. And we can see that for specimens C and D, for integrity and insulation, they have 0 minutes and 0 minutes because they have failed both the integrity and the insulation requirements, yes?
If you fail the integrity requirement of any test, even today, you automatically fail the insulation criteria.
I understand. And it tells us there's 2 asterisks for each of those 0 minutes. And if we read down 2 paragraphs below, it says there, due to the intended end use of specimens C and D, both specimens were tested incorporating a 25 millimeter through gap along one edge at the start of the test. As a result, both specimens automatically failed the integrity and insulation criteria of the test via penetration of a 25 millimeter gap gauge upon commencement of the test. So you could put the rod through the 25 millimeter gap. It's an automatic fail if you were applying the 476 part 20 standard, yes?
Yes.
And in the paragraph below that, we can see it reads it says this: after 6 minutes of testing, both specimens had fully sealed this gap, and therefore if they were assessed against the integrity and insulation maximum temperature rise only performance criteria of BS 476 part 20 from this point, then the results of 46 minutes integrity and 32 minutes insulation for specimen C would be achieved, and 54 minutes for integrity and for insulation for specimen D would have been achieved, yes?
Yes.
So we can see from that paragraph that it took 6 minutes for both specimens to fully seal the gap, yes?
Fully seal, that's a depth, fully sealed to the full depth of the 75 millimeters.
Yes. So
not actually activate. The intumescents activate, like I said previously, between 125 and 130 degrees.
I see.
So you would have activation at the bottom edge, and then that would seal the furnace, and then over a period of warming, then you would get the full depth of the 75 millimeter thickness develop.
Yes, I understand. So for the full width of that barrier to
yes
to seal against the concrete face, that took 6 minutes, yes?
Yes.
And is it right that only the maximum temperature rise requirements of BS 476 part 20 were used in this ad hoc testing?
Yes, it was.
And we can see what the performance was that they achieved. And then if we can look at page 28 of the report, we can see there's some limitations. Mr. Chairman, if I can just cover these limitations in this report, perhaps then we could break.
Yes, that's right.
So at page 28, we can see at the bottom, it sets out ongoing limitations, and we can see at paragraph 1, it states the results relate only to the behaviour of the specimens of the element of construction under the particular conditions of test. They are not intended to be the sole criteria for assessing the potential fire performance of the element in use, nor do they reflect the actual behaviour in fires. And then we can see in the next paragraph, it says the results may not be applicable to situations where the joint widths, orientations and supporting construction vary from those tested. And then in the third paragraph, it says, as no movement was induced into the specimens during the test, there can be no evaluation of the performance of the seals where movement is included in a building under actual fire conditions. So can you just help us, what did you understand that last limitation to mean?
It's a standard clause. It's a standard clause in fire tests, even now. You're testing to get the performance of the element in isolation. It needs further assessing, as it says there, the fire performance of all the elements put together.
Yeah.
So you have the fire performance. If we take rain screen for example, you would have the fire performance of the supporting wall, whether that be concrete or SFS. You'd have the fire performance of the insulation in the cavity. You'd have the fire performance of the cavity barriers, and you'd have the fire performance of the rain screen panel. And then it's for the overall project fire engineer or consultant to assess all those products brought together, because you can't test all of them together on a fire resistance test only through an 8414.
Right, I see. And then just to complete what we can see in this report for our purposes, if we go to page 29, the next page at the top of the page, under review, it makes clear that this report covers a test which was conducted to a procedure which is not the subject of any British standard specification, but it utilised the general principles of fire resistance testing in 476 part 20. And it also refers there, and you mentioned this standard earlier, the European equivalent, BSEN 1366. Actually, that's part 4 on linear joint seals, isn't it?
Yes.
There. And is it right that in this test, you use the thermocouple locations from the BSEN 1366 part 4 for linear joint seals? You use the thermocouple locations on top from that standard, and the heating from BS 476 Part 20, and then you adapted the procedures from the two different standards for this test?
We didn't adapt any of the procedures because we do not run the test. Warrington Fire run the test. We only witness. In terms of thermocouples attached to the product, the thermocouples for EN attached to the product are a copper disc with wires attached and a non-combustible pad of about 30 millimeters square. They are the same or similar to the BS 476. So really, there isn't any difference between the two measuring thermocouples.
I appreciate that's your evidence, but is it right that you effectively Warrington Fire used thermocouple locations from that 136 Part 4 standard and the heating requirements from 476 Part 20?
Yes.
Yes, thank you. And then we can note just the final point that at the end of that paragraph, it says it's recommended that the report be referred back to the test laboratory after a period of 2 years to ensure the methodology adopted and the results remain valid. Yes?
Yes.
Thank you. Mr. Chairman, that's a good moment, I think, for a break because I'm about to move on to another test report.
Yes, all right. Well,
break.
Thank you. I said we'd have a break roughly the middle of the morning. Mr. Mort, we'll take it now. We'll come back at 20 to 12, please. And I have to ask you on this occasion, and indeed any other occasions that when we have breaks, not to talk to anyone about your evidence, please, or anything to do with it while you're away from the room. All right?
Yeah, understood.
Good. Thank you very much. So we'll see you at 20 to 12 then. Thank you.
Okay.
Thank you. Welcome back, everyone. We're now ready to go back to Mr. Mort to continue his evidence. Are you there, Mr. Mort? Can you see me and hear me?
Yes, I can.
Good, thank you very much. Ready to carry on?
Yes, I am.
Good, thank you very much indeed. Yes, Ms. Grange, when you're ready.
Yes, thank you. Yes, Mr. Mort. So we were just looking at the 2007 test report from Warrington Fire before we broke off, and we looked at a number of the ongoing limitations that Warrington Fire had spelt out at the end of that report. Can you just help us with this? To what extent did did Siderise take on board those limitations that were spelt out in that test?
As with all fire tests, we take on board the limitations of the test.
Yes, and we're going to come to the marketing literature that Siderise produced later. To what extent were those limitations discussed when the marketing literature was being drafted?
I only technically reviewed the literature. I wasn't involved in the drafting of the literature.
I see. So you don't recall any discussions at that stage about the limitations that were clearly spelt out in these reports?
No.
So let's go to the second Exover Warrington report that we have. This is from January 2009. If we go to SIL 50223, yes, thank you. So we can see from the title that this is a report that considers the fire resistance performance of Siderise Lamatherm CWRS. Where we see CWRS, is that curtain walling rain screen?
That's correct.
Yeah. Cavity barriers complete with Technofire and then a number intumescent. And we can see that the report is dated 30th of January 2009 from the bottom right. And we can see it's described as an assessment report. Now, were you involved in the obtaining of this report?
In January 2009, I was working for Hilti.
I see. But did you become aware of this report when you rejoined Siderise?
Yes.
Yes, thank you. And if we go to page 3 under the executive summary, there's a heading there right at the top, objective. It says this report considers the expected fire resistance performance of Siderise Lamatherm CWRS cavity barriers complete with Technofire intumescent, similar to those tested under the reference WF number 17714 with increased depth to 90 millimeters. Now that report reference 157714 is the test report from February 2007 that we were just looking at just a moment ago. That's right, isn't it?
Yes, it is.
So this report was building on that work, but now the depth of the intumescent was increased to 90 millimeters. Is that correct?
Upon reading this report, it would be, yes, it was increasing the depth of the seal from 75 to 90 millimeters for a different fire rate.
Yes, so it's a deeper cavity barrier and a deeper intumescent, yes?
No, the intumescent would be the same.
Oh, I see. It's just for a deeper cavity barrier.
For a thickness of the cavity barrier.
Yeah, I see. And can you help us to why it was, I appreciate you weren't there, but were you ever told why it was that Siderise commissioned this assessment report?
It would only be for requests from the market for a 60-minute installation integrity product.
Right, I see. And is it right that for this report, there weren't further tests carried out? This was just an analysis of whether the intumescent should be capable of providing up to 60 minutes integrity and insulation. Is that right?
Yes.
And if we turn to page 5 under the heading proposals, we can see effectively the proposition that's being tested and assessed in this report. It is proposed that those cavity barriers complete with Technofire intumescent, similar to those previously tested under the previous test, but increased in depth to 90 millimeters should provide up to 60 minutes integrity and insulation performance. And then note these words, when installed between concrete floor slab edges and concrete masonry walls, if tested using the general principles of BS 476 Part 20, 1987. Yes?
Yes.
So again, with this assessment report, it's premised on the basis that the product was held between two concrete slabs, yes?
For testing, yes.
Yeah. And if we turn to page 7, we can see the report's conclusions. And the basic conclusion was that should the recommendations given in this report be followed, it can be concluded that those cavity barriers, complete with the Technofire intumescent, should be capable of providing up to 60 minutes integrity and insulation performance if subjected to a test utilising the general principles of BS 476 Part 20. And again, the little asterisks, we can see caveats this and makes clear that it's after closure of the 25 millimetre wide air gap has occurred. And in brackets, it says after approximately 4 minutes, yes?
Yes.
So the report is not assessing integrity or insulation performance prior to the 25 millimetre gap being closed, no?
No.
And again, the report contains a caveat. If we go to the very last sentence on page 7, under validity, it says the appraisal is only valid provided that no other modifications are made to the tested construction other than those described in this report. So that's an assessment report that's obtained in 2009. Let's move now to another test report. This is SIL 50224. And we can see from the title there on the right-hand side, this is fire resistance test utilising the general principles of BS 476 Part 20 on 5 specimens of floor-mounted linear gap seals. And we can see it's dated the 26th of August 2010. And so it would appear that Siderise had commissioned further testing to the principles of BS 476 Part 20, which led to this report being produced. Is that right?
That's right.
And if we look at page 2 of the report, under test results, we can see if we, that's great, yes, if we zoom in there, we can see that 5 samples were tested. Specimen E at the top there, we can see that that was installed into the cavity on 3 brackets, reference prototype RS, leaving an air gap of nominally 50 millimeters. Do you see that there?
Yes.
And then specimens F, G, H, and I are all described below that. And they had an air gap of nominally 25 millimeters, yes?
Yes.
So you're testing the barriers with different widths of air gap, is that correct?
That's correct.
And turning just to page 12, we can see at the bottom of page 12, at item 6, again, the apparatus used in this test included concrete lintels, autoclaved aerated concrete, yes?
Yes.
And then if we turn to page 23, we can see a table of results. So here we can see that all the specimens, when they've been tested to BS 476 Part 20, have got 0 minutes integrity and 0 minutes insulation, and there's an asterisk. And we can see below in the paragraph below the table, in the first paragraph, if we could just go down the page a little, thank you. It says there, due to the intended use of specimens E to I, the specimens were tested incorporating a through gap along one edge of between 25 millimeters to 50 millimeters at the start of the test. As a result, the specimens automatically failed the integrity and insulation criteria of the test via penetration of a 25 millimeter gap gauge upon commencement of the test. So exactly the same as last time, yes?
Yes.
And then if we look at the final, the paragraph below that, it states this, it says between 2 and 3 minutes, specimen G, H and I sealed the gaps. And therefore, if they were assessed against the integrity and insulation, maximum temperature rise only, performance criteria of BS 476 part 20 from this point, then the results are, and we can see that the results are 61 minutes integrity and 23 minutes insulation for specimen G, 61 minutes integrity and 20 minutes insulation for specimen H, and 61 minutes integrity and 27 minutes insulation specimen I respectively would have been reported. So just to summarize, and is this fair, in these tests, these samples have done quite well in terms of integrity. They've all got over 61 minutes, but they've performed worse in terms of insulation, only 23 minutes, 20 minutes and 27 minutes respectively. Can you see that?
Yes.
And is that a fair summary, the summary I've just given?
Yes.
And then it tells us right at the end of that paragraph, last sentence, specimens E and F failed to completely seal the gaps. So in respect of specimen E, that was with the 50 millimeter gap, the intumescent did not expand enough to fill that gap, is that right?
That's correct. These are purely R&D product development testing. We're trying out new intumescent technology to improve the product that's been supplied to the market. That's the purpose of these tests.
Right, I see. So what was new in these tests compared with the ones that you did in 2007?
A new type of intumescent from a new intumescent supplier.
Right, I see.
So it's it's product development.
Yes, I understand. And then if we go over to page 24 of this test, we can see that exactly the same limitations and disclaimer are placed here by Warrington Fire as before. The results relate only to the behaviour of the specimens of the element of construction and not intended to be the sole criteria for assessing the potential fire performance. And then the results may not be applicable to the situations where the joint widths, orientations and supporting construction vary from those tested. And then it's making clear in that final paragraph under limitations that there was no movement and therefore it can't be evaluating the performance where movement is induced in a building under actual fire conditions, yes?
Yes, those are standard clauses in all test reports.
Yes, I understand they're standard clauses, but they're pretty important clauses, aren't they, nonetheless?
They're standard clauses in the test reports. You are testing that single element, that single item.
Yes.
It needs to be further assessed, as I said previously, by a project fire engineer who takes the fire resistance properties and fire reaction properties of all the elements being used in the construction to come up with the correct product.
Yes. Can we agree that they're important limitations?
Yes.
Yeah. And then in the fourth report, if we go to this now, this is from September 2011. If we look at SIL 50211, and under the title, we can see on the top right-hand side, the title is the fire resistance performance of Lamatherm rain screen fire barriers. And we can see below that this is an assessment report again. And we can see it's dated the 20th of September 2011. Now, again, have you seen this report before and are you familiar with it?
Yes.
Were you involved in commissioning this report?
Yes.
And again, it's an assessment report, isn't it? Not new testing, but an analysis and extrapolation based on evidence presented to Exova.
Yes.
And if we go to page 3, next to objective, what it's saying as the objective for this assessment report is that it considers the expected fire resistance performance of Lamatherm rain screen fire barriers similar to those tested under the references. And those are the two test reports the first from 2007 and the second from 2010 that we've just been looking at, yes?
Yes.
And on page 4, we can see the assumptions that this report is based on. And next to supporting construction, it says it is assumed that the assemblies that the cavity fire barriers will be fitted to elements of construction that have at least 60 minutes fire resistance performance in accordance with BS 476 part 21 and 22. So there it's making an assumption that the assemblies that they're going to be fitted to will have at least 60 minutes fire resistance performance, yes?
Yes.
And next to installation, 2 down from that, it says it's assumed that the barriers will be installed by competent installers in a professional manner. And then it says the use of third-party certified installers is recommended. Do you see that?
Yes.
And it also says it's also assumed that the gap between the end of the barrier and the element of construction is no greater than 25 millimeters, yes?
Yes.
And then next to rain screen, below that, it says this report does not consider the fire resistance performance of the rain screen element or whether fire spread may occur as a consequence of collapse or failure of the rain screen. The approving authority or regulator should decide whether it is necessary for the rain screen to be, quote, fire rated, whether it is of an appropriate construction and whether separate test or assessment evidence is necessary. Now, were you aware of that caveat at the time in this report?
Yes.
And if we can turn to page 7 of this document in the top paragraph, we can see it says, it should be noted that due to the performance criteria of the standard, the opening included at the start of the test must result in integrity and installation failure, irrespective of how quickly the gap was closed, and the approving authority or regulator should therefore consider the acceptability of this situation. Now, we've seen 2 references there to the approving authority or regulator in this test assessment. Who did you understand to be the approving authority or regulator in this context?
On a project where product is supplied, there can be a approval by the project fire engineer, could be approval by local building control, could be approval by other consultants. It's they're responsible for assessing every element. So you may have, if you had 5 different manufacturers of 5 different components, it's their responsibility to assess all 5 components to ensure that it meets with the fire strategy.
Yes. Was it Siderise's practice to bring these caveats to the attention of fire engineer or building control officers on projects that it was involved with?
We have, yes.
When you say we have, does that mean it was your practice to do that as a matter of course, that you would do that?
Whenever we were in discussions with a fire engineer, things like that, it's a case of this is the product test information. You need to satisfy yourselves that it's suitable for the construction on site, because we're not in control of what is being installed into.
So does that mean you do routinely tell building control that the integrity and insulation failure would occur at the beginning of the test and that the test data only relates to what happens later?
They would have seen the test reports.
When you say they would have seen the test reports?
We share test reports to projects on a regular basis.
Right, I see. Do you share test reports routinely and on all projects?
Yes.
Or only when asked?
When asked, when requested, our information, particularly since Grenfell, is readily available for download off our website.
And you say our information, particularly since Grenfell, is readily available for download off the website. Does it follow that some information wouldn't have been readily available prior to Grenfell?
All information was readily available. We were open in sharing our test evidence with any relevant body who would ask for the test evidence. quite often under confidentiality agreements.
Yes, I see. And then if we can go back to the report we were just looking at, in the next paragraph down from where I was reading on page 7, it says this: despite the effectiveness of the intumescent in this test, the insulation performance was worse than of specimen D in the test referenced, and then it's giving a reference to the February 07 report, which achieved 54 minutes. So it's saying the insulation performance was worse than that of specimen D. Then it goes on, it says, since the stone wool insulation is the same and the gap was closed more quickly in the test referenced, and then they're referring to the 2010 test, the earlier insulation failure must be due to another difference, the most likely cause being the splitting of the edge of the barrier by the pressure exerted by the intumescent strip. And then it goes on, the use of a foil end cap in the test referenced, and then it refers to the 2007 test, will have prevented or reduced this effect, and therefore the inclusion of this detail with the proposed barrier would be expected to result in an insulation performance of at least 30 minutes, in addition to the 60 minutes integrity performance already discussed. Now, can you help us? What is is it a foil end cap or a fell end cap?
Like I said, this test was the test was a product development test, and when we manufactured these barriers for this product development test, where you have a foil face on the top of the barrier and a foil face on the bottom of the barrier, in the previous test we had linked the two faces with foil tape over the end of the product, to which the intumescent was applied. On this R&D test, we didn't use the same foil end closure to the seal, so we only had the foil on the top and the bottom of the product. What that resulted in is the intumescent, when it expands, produces hot gases, warm gases, and those gases, because stone wool can allow for gas to penetrate into it without any barrier, that's what happened. And we've proven on multiple occasions, and we've actually had competitors copy our barriers, where you introduce a foil cap on the end to stop the intumescent effect in the insulation performance.
I see. So does that mean that you now have, is it a foil end cap routinely provided as part of the barriers?
Yeah, if you carried on through that report you were showing, it's got a drawing in there of showing how the product was made up.
Right, I see. Yeah. And if we go back to those conclusions that we were just looking at, at the end of that page, it says, should the recommendations given in this report be followed, it can be concluded that Lamatherm rain screen fire barriers, as described in this report, should be capable of providing 60 minutes integrity and 30 minutes insulation performance after closure of the ventilation gap has occurred, if subjected to the test using general principles of 476 part 20. Now, did Siderise agree with that conclusion, that the cavity barrier should be capable of achieving 60 minutes integrity and 30 minutes insulation performance?
Yes, and it's worth noting that is double the performance of the requirement for a cavity barrier as described in approved document B.
Yes. Can we just look at, I want to put 2 pages on the screen side by side from the test reports 2007 and 2010. If we could pull up the 2007 test report, this is page 4 of SIL 50290. Yeah, so if we can have that. And then on the other side of the page, if we can have the 2010 test report at page 3, SIL 50224, page 3. Yes, and it's the last paragraph on both of those pages that I'm interested in. So if we look first at the 2007 report on the left-hand side, we can see at the bottom paragraph of the page, the report set out that after 6 minutes of testing, we can see that specimen C has achieved 46 minutes integrity and 32 minutes insulation. And then it's got 54 minutes integrity and insulation, so 54 for both. It's specimen D. Yes.
Yes.
And then if we look at on the right-hand side in the 2010 test report, in that bottom paragraph, we can see that specimen G, this is about halfway down, where it starts saying then results of 61 minutes integrity and 23 minutes insulation. That's specimen G. 61 minutes integrity and 20 minutes insulation, specimen H. And 61 minutes integrity and 27 minutes insulation for specimen I. So those are the figures. Now, we can see that for insulation, the results were much better in the first test. And for integrity, the results were much better in the second test, yes?
Yes.
And so is it right that in its assessment report from 2011 that we've just been looking at, Exova combined the favourable integrity results from the 2010 test report, the 61 minutes, with the favourable insulation results from the 2007 test report, 32 and 54 minutes, to conclude that Siderise open state cavity barriers would achieve the 60-30 for integrity and insulation, yes?
Yes, as we previously discussed, the test on the right-hand side did not have the foil cap. The test on the left had the foil cap. That is the fundamental difference between the two. Also, the test on the right was using new, higher performing intumescent we were trialing.
But is it right that no specimen had actually achieved that result, 60-30, for both criteria? No single specimen had achieved that?
That's correct.
Was this any concern to Siderise that you hadn't got a single product that had got both 60-30, that you'd had to take results from two different tests to achieve that?
Like I've said, they were two totally different samples were tested. We've proven after this that the performance is even better than this again. These are R&D tests. This is learning. This is how products are developed. You test, you learn, you test, you learn, and you just don't stop learning. You continually test and you continually learn.
I understand, but so are you saying that you did retest the products to see if you could get a single specimen to achieve 60-30?
At a later date, yes.
When was that later date?
I can't recollect from memory, but we have extensive tests on file that have been submitted to the inquiry.
Was that before or after the Grenfell fire?
Before.
Right. And what about before or after the product was supplied to Grenfell?
We've tested continually, we still continue to test.
I see. I want to take you now, or ask you now some questions about testing to a standard known in the industry as TGD 19. If we can start by looking at paragraph 49 of Mr. Swales's witness statement. This is page 13 of his statement, SIL 50306. And I just want to look at what he says in the first few lines of that paragraph 49. He says, the BS 476 part 20 and or BS EN 1366 part 4 standards were not, however, deemed adequate by the test houses for the testing of open state cavity barriers. This was largely because the air gap requirements meant an automatic failure of the test. And just pausing there, when he says were not deemed adequate by the test houses, do you know which test houses he's talking about there?
In the UK, we have we did have three main test houses. We had Warrington Fire, BRE, and Chiltern Fire. Now we have 2 because Chiltern Fire are part of the element group which own Warrington.
Do you know whether it was the view of the BRE and Chiltern Fire as well as Rexover?
That comment has come from, at this time I was sitting on ASFP technical committee working groups, and the working groups are made up of laboratories, consultants, product manufacturers, consultants, and such like. There would have been representation from the BRE there. There would have been representation from Warrington, representation from UL, although they don't have any laboratories in the UK, and representation from Chiltern at the time.
Right. When you say representation from UL, who are you talking about there?
Universal Laboratories, American
Right.
company. They have a certification fire engineering division in the UK, although they don't have any test facilities
I see.
present.
So is it your understanding that all of the test houses didn't consider the British standards to be adequate for the testing of open state cavity barriers?
Yes.
And then Mr. Swales goes on to say, if we pick it up 3 lines down from where we stopped before, he says, accordingly, in 2014, the Association for Specialist Fire Protection, ASFP, who you've just mentioned, developed and launched a new test regime, namely Technical Guidance Document, TGD, specifically for the testing of open state cavity barriers. This is now known as the ASFP Guidance. Open state cavity barrier used in external envelope or fabric of buildings, utilising the principles of EN 1363 Part 1, TGD 19. Now, can I take it that you're familiar with that technical guidance document, TGD 19?
Yes.
We will go to it in a moment. And Mr. Swales goes on to say, if we look at paragraph 50, on that same page, at the bottom, he says, Siderise worked with the ASFP to develop TGD 19 and tested its cavity barriers to draft standard ASFP TG3 N64, 4th draft February 2013, to the temperature and pressure conditions of BSEN 136 Part 1 2012 on the 15th of May 2013, and then he gives reference to an Rexover report. Now, were you personally involved in developing TGD 19?
As part of the technical working group for ASFP, yes.
Yeah.
Along with 11 other members.
And I think that standard that I just read out, BSEN 1363 Part 1 2012, that's the European equivalent of BS 476 Part 20, setting out the general requirements for fire resistance tests, yes?
It's a higher standard than BS 476 Part 20.
I see.
But if you have a product that is tested to BS 476, you cannot assume it will pass a BSEN 1366 test. If you've got a product that's tested to EN 1366 or similar, then it should pass the BS 476 due to how the furnace temperature is recorded and controlled. In BS 476, it's a simple bare wire. In EN standards, there is a thermocouple in there that is a 100mm square steel plate with a 10mm calcium silicate board, and sandwiched between the steel plate and the calcium silicate board is the bare wire thermocouple. So the amount of energy needed in the first phase of the start of an EN test is 20 to 25% more than required in a BS 476 test.
Right.
That's a considerable thermal shock increase over BS 476.
I understand. Now, if we go to paragraph 39 of your witness statement, this is on page 10 of your statement, you explain there for us some of the difficulties in testing open state cavity barriers. And what you say in the beginning of that paragraph is, you say difficulties in testing open state cavity barriers is not limited to the UK. European testing standards have also struggled, as I set out below. And I wanted to look at what you say at subparagraph C. If we look at that, you say, in October 2008, the European Organisation for Technical Assessment, the EOTA, published a technical report, TR31, entitled Fire Resistance Tests for Cavity Barriers. As I understand it, TR31 was written because there was no relevant standard for testing cavity barriers. However, that standard, you say, excludes open state cavity barriers. It states at section 1, this method is not applicable to horizontal cavity barriers, e.g. rain screen cladding, because it is difficult, if not impossible, to model the correct thermal exposure and boundary conditions in a fire resistance type test. Such tests should be considered as part of a facades test. Now, is that the view of Siderise, that it would be difficult, if not impossible, to model the correct thermal exposure and boundary conditions?
That there is the opinion of the EOTA committee that wrote the TR31. Members of the TR31 committee were also members of the ASFP, who were involved in writing TGD 19. The difficulty being goes back to the fundamental principles of having an open gap on a furnace. How do you measure the temperature above that gap in order to keep the pressure and the temperature in the furnace balanced to allow it to follow the time temperature curve?
Yeah.
That is the issue. In terms of such tests, which you could do a part of facade tests, an EN test to using 1363 part 1, up to around 5 minutes, it gets up to close to 650 degrees, or then to half an hour, it gets up to 850 degrees. It's a logarithmic time temperature curve. On a full facade test to 8414, the failure criterion at level 2, which is where it's measured at, does not exceed 600 degrees. So therefore, an 8414 test, failure criteria at level 2 is less than what a furnace gets to in the first 5 minutes. So therefore, if you test a cavity barrier on a furnace condition, the cavity barrier will not have any detrimental effect to a full-scale test of a facade to 8414.
I follow that, but my question was whether Siderise agreed with the position of the EOTA as expressed in that paragraph, that it would be difficult, if not impossible, to model the correct thermal exposure and boundary conditions in a fire resistance type test.
It's not just Siderise's opinion, it was the ASFP opinion that you could model and get the furnace balanced.
But I think the short answer to my question is yes, that was Siderise's opinion, yes?
Siderise's opinion as in we agree with the EOTA statement or not?
Sorry, well, please
I don't
clarify.
agree with it. I don't agree with it.
Did Siderise agree with that opinion or not?
No.
They didn't?
No.
And
A furnace test is harder than a facade test to 8414. Just purely to temperature exposure.
Well, the bit of, let's just go back to that bit of your statement. What's being said there, if we go, sorry, back to the previous page, bottom of the page. So you say in October 2008, the European Organisation for Technical Assessment published a technical report entitled, and there's the report, and then we go back over. As I understand it, it was written because there was no relevant standard for testing cavity barriers. However, it excludes open state, and it states at section 1, this method is not applicable to horizontal cavity barriers, e.g. rain screen cladding, because it is difficult, if not impossible, to model the correct thermal exposure and boundary conditions in a fire resistance type test. Such tests should be considered as part of a facades test. So taking that in stages, did Siderise agree that it was difficult, if not impossible, to model the correct thermal exposure and boundary conditions in a fire resistance type test?
No.
And why did Siderise take a different view?
This was the view of an European committee who were not aware of tests that would be undertaken in the UK in terms of trying to develop products. Once intumescent reacts and closes the gap, then in effect that is a full seal. Then the full furnace conditions can be controlled.
I see. So Siderise thought it would be possible.
Yes,
if
we know.
If you ignore the first few minutes of the test, to model the correct thermal exposure and boundary conditions in a fire resistance test?
You don't ignore everything's recorded from time zero. So it's not ignored, because if it was ignored, then they wouldn't be putting 0, on the installation integrity on the test report. We were trying to come up with a way of the ASFP, and like I said, members of the ASFP actually were involved with TR31 to introduce additional thermocouples that actually measured the temperature in the 25mm open gap.
I see.
And that then assists the control of the furnace and running of the test.
What about the part there, such tests should be considered as part of a facades test? What did Siderise agree with that statement?
To an extent, yes, although the failure criterion on an 8414 test is never the cavity barrier, because the cavity barriers used in 8414 tests have been tested to a furnace condition, which have temperatures that are higher than the failure criteria of an 8414 test. Then the cavity barriers, all the time, function as a cavity barrier. In all 8414 tests that fail, it's a combination of either the panel is on fire, or there's a fire within the panel, or there's thermal insulation and panel fire. The cavity barriers function to the point of the panel failure.
Right. Yes, I mean, I think we can agree, can we, that an 8414 test is not set up to measure the performance of the cavity barrier, is it?
That's correct.
It's a system test.
It's a system test.
And the data that you get from an 8414 test is very different from the data that you get from a fire resistance test. That's a reaction to fire test, isn't it?
They're two totally different tests. However, you need cavity barriers in an 8414 test in order for an 8414 test to function.
Well,
even though they're not measured, they need to be part of the test in order for the test to function.
Yes, I understand that. But going back to what the European committee or the European Organisation for Technical Assessment, what did you understand them to mean when they said such tests should be considered as part of a facades test? Forget 8414 for a moment. What did you understand them to mean by that?
That you can't just take a furnace test for a product. You need a furnace test and possibly a full facade test, although through EN standards, there are no facade tests yet. There still aren't.
I understand that, but I think you've just agreed that what they're saying is you can't just take a furnace test for a product. You need the furnace test and possibly a full facade test, yes?
But then the failure criteria of a facade test is nowhere near the level of performance of a furnace test. So therefore, a cavity barrier that passes a furnace test, it can be safely assumed, will not be detrimental to the performance of a full system test.
Yes, I understand that. If you think of them referring to a facades test as being an 8414 test, is that what you understood them to mean? Did you ever clarify that?
I didn't clarify that, no.
Right. Now, if we go to paragraph 40 of your witness statement now, you address TGD 19, this new test.
New guidance rather than a test.
On page 10, yes. Sorry, new guidance. You say this, therefore, the above mentioned test standards do not address the requirements for testing open state cavity barriers. Accordingly, the ASFP, together with its technical committee of UCAS laboratories, certification engineers, manufacturers, CEN and BSI members, authored a guidance document, TGD 19, that specifically addressed small-scale furnace testing of open state cavity barriers. The usual method of undertaking a test in accordance with TGD 19 is again to undertake the test of the barrier by supporting it between two concrete elements. Until TGD 19 was published, there was no test directly applicable and appropriate to open state cavity barriers. Now, in terms of that group that authorised TGD 19, you talk about the fact it included UCAS laboratories, certification engineers, manufacturers, etc. Which manufacturers were part of that group?
Siderise, Hilti, Rockwell, Firetherm, Firestop It, Promat.
Yes. And can you explain exactly what type of small-scale furnace testing was selected for open state cavity barriers?
When we say small scale, we are still talking a significant major test. It's small scale compared to a 10-meter high 841 test rig. It's still a at least 1 meter or 1.2 meter cube gas furnace that gets up to temperatures of 850 degrees over 30 minutes, 1,000 and 1,100 degrees over 2 hours. They're still, even though it says small scale, they're still major tests.
I see. And can you explain why that form of testing was considered appropriate by this group?
Because it gave clarification to the performance of the cavity barrier in isolation. So if you've got manufacturers A, B, C, D, E, everybody tests the same principles on there, and A, B, C, D, E all get 30 minutes on there, then it gives more clarity to the market as to the performance of those barriers, because they're all following the same standard, same guidance.
Yeah. And you say in that part of your statement, I just read it out, that the usual method of undertaking a test in accordance with TGD 19 is again to undertake the test of the barrier by supporting it between two concrete elements, yes?
Yes.
You described that as the usual method. How many methods were there of undertaking a test in accordance with TGD 19 when it came to the barrier's supporting elements?
You had concrete to concrete in there, and also you could erect a timber substrate protected with cement particle boards, which the barrier would be fixed through, but the intumescent would still exfoliate to concrete.
I see. Yeah. Did Siderise ever test its cavity barriers to a test method which wasn't between two concrete elements?
Not on the furnace, no.
No. Now, let's turn to another X-over report now, this time from July 2013. This is SIL 50212. And we can see from the title on the right-hand side that this is, the heading is the fire resistance performance of 4 specimens of floor-mounted open state cavity barriers tested utilizing the general principles of draft standard ASFP TG3 N64 4th draft 2013. Now that was the draft standard that was the precursor to TGD 19, yes?
Yes, that's correct.
Yeah. And we can see from the bottom right hand side of this first page that the date is the 23rd of July 2013.
Yes.
And if we can turn on to page 6, we can see next to the instruction to test in the middle that you were one of the witnesses to this test. You're listed there with Mr. Carrick and Mr. Spack, yes?
Yes.
And can you remember attending this test? Do you have a memory of it?
Yes, I do.
And if we turn to page 2, we can see the description of the test setup. And under the heading, the third heading down in the blue, summary of the tested specimen, we can see that from the second paragraph down, that the section of the floor had overall dimensions of, and it gives the dimensions, and was made up of autoclaved aerated concrete lintels arranged to provide 300 millimeter wide by 1,200 millimeters long and 125 millimeter wide by 1,200 millimeter long apertures. Yes. So again, we've got rectangular apertures cut into concrete lintels. Yes.
Yes. The precedent for testing between concrete elements started a long time before I joined the industry. BS 476 Part 20 was published in 1987. So from 1987 onwards, to isolate elements that you want to test, you test it between concrete elements. So the weakness is your product, not the concrete.
Right. But just to be clear here, we've got three 300 millimeter wide openings and one 25 millimeter opening. Is that right?
Yes.
And then if we turn briefly to your witness statement at paragraph 10, we'll come back to this in a moment, SIL 50298, page 3. You tell us at paragraph 10 what the types of cavity barriers were that were supplied to Grenfell Tower. And we can see you've got reference there in the bullet points to RH 25G 9030 264 to 325, and then a slightly different barrier below. Now, just to explain how this product is named, the RH at the beginning means rain screen horizontal, yes?
Yes.
And at the last 2 bullet points, it's rain screen vertical, yes?
Yes.
So RH or RV tells you whether it's horizontal or vertical. The 25 for the horizontal, that's the 25 millimeter air gap, yes?
Yes.
And then G stands for galvanized, is that right?
Correct.
And then you've got the minutes that it's rated to. So for integrity and insulation, 90/30, we can see at the top. Do you see that? And then the final numbers at the end, they represent the void size, the overall void size that the barrier has been used in, yes?
Yes.
So you've supplied barriers at Grenfell Tower, the horizontal barriers, for a void size of between 264 and 325 millimeters, and also between 326 and 425 millimeters, yes?
Yes.
Yes, and we're going to talk about void size a little bit later, but it's worth noting those at the moment that they go up to 425. Now, then if we go back to the test report we were looking at, SIL 50212, page 2, we can see in the 5th paragraph down, sorry, so it's actually the 3rd paragraph down in that part of the page, beginning specimens A to C. Basically, we get various dimensions of cavity barrier given in this section. And specimen A, they're all full-faced rock fiber lamellar rain screen cavity barrier. And they give the reference, which had a nominal density of 75 kilograms per meter cubed and an overall dimensions. And then we get the dimensions of 275 millimeter wide by 120 millimeters long and 120 millimeter thick. That's specimen A, 90 millimeter thick specimen B, and 75 millimeter thick specimen C. Mr. Swales has confirmed at paragraph 51 of his witness statement that the two types of horizontal cavity barrier that were used on Grenfell Tower were specimens A and C. Does that sound right?
Yes.
Yeah. So it's A was 120 millimeters thick and specimen C 75 millimeters thick. Now, if we turn on to page 31 of the test report, I want to look at the section headed integrity first at the top of the page. It says there, it's required that the specimen retains its separating function without either causing ignition of a cotton pad when applied as specified in EN 1363 part 1, 2012, or resulting in sustained flaming on the unexposed surface. And then these requirements were satisfied for the periods shown below. And then it says technical failure of the integrity of specimens A to D were deemed to have occurred at the start of this test due to the open void required for such seal types. However, following expansion of the intumescent layer, full closure of each cavity was deemed to occur between 1 minute and 4 minutes 38 seconds. Now, just on that, can you help us with why the intumescent layer was deemed to have closed the cavity at these time periods?
You would need to, or I would need to see it, the thermocouple, suspended thermocouple data for each of the cavities, which are appendix to this report. In there, in the ASFP TDD 19, there is a requirement that whilst it's accepted that the thermocouples that are suspended may peak over the 180 degrees in the first initial lighting of the furnace, but they drop back very rapidly. From the thermocouple data, you'll be able to establish not only when the insulation criteria is re-established, but when the integrity criteria is established. Because as soon as that drops below 180 degrees, then the integrity is there.
I see. So what you're saying is that the test assumes that as soon as it drops below 180 degrees, then it's assumed that the intumescent layer has sealed the cavity.
Yes.
And that was deemed to have occurred between 1 minute and 4 minutes 38 seconds in this testing.
Yes.
Yeah. And then looking at the two tables on this page, so looking at this table for integrity first, we can see that, and we're concentrating on specimens A and C. These are the barriers that were used at Grenfell Tower. Specimen A achieved 136 minutes integrity, and specimen C 116 minutes integrity. And then if we look down to the table below, which deals with insulation, we can see that specimen A has achieved 81 minutes insulation and specimen C 57 minutes insulation. Is that right?
Yes.
And if we turn to page 32 under ongoing implications, we see the limitations section. And again, we see very similar, in fact, identical limitations to those that we saw in the earlier Warrington Fire test reports, yes?
Yes.
So the results relate only to the behaviour of the test specimens under construction in the conditions of this test. They're not intended to be the sole criteria for assessing the potential fire performance of this element in use. They do not, nor do they reflect the actual behaviour in fires. They may not be applicable to situations where joint widths, depths, orientation, supporting construction may vary. And it also makes the point that there was no movement induced. So it's not telling you about how they would perform where movement is induced in a building under actual fire conditions. And then if we go to page 34, we can see there's a heading on this test report headed field of direct application. And it says that the results of the fire test are directly applicable to similar constructions where one or more of the changes listed below are made. A, increase in the thickness of the cavity barrier, decrease in the distances of fixing centres, decrease in the width front to back of the air gap. And then it says D, void sides can be interpolated between minimum and maximum voids. And then E, if a single void size is tested, the result is only applicable to that void size. Do you see that at E?
Yes.
And again, did you note and understand those limitations of this test reporting at the time?
Yes, because that is a direct field of application applicable to that test report only.
And did you make your colleagues in the sales and marketing team at Siderise aware that the results of these tests were only applicable in those circumstances?
They would have been aware, yes.
When you say they would have been aware, what makes you say that?
Well, the test reports would have been reviewed by the Siderise team.
Including all of those in the marketing team?
Yes.
And then next to the heading, so directly underneath that, if we go back to that page, under the heading supporting construction, it says the test results obtained with autoclaved aerated concrete standard supporting constructions apply to concrete blockwork and masonry separating elements of a thickness and density equal to or greater than that tested. Do you see that?
Yes.
So it's the test results are limited to concrete blockwork and masonry front and back, yes?
For if you would test that product on a furnace, yes.
Yes. And just to be absolutely clear, this test did not extend to considering the use of open state cavity barriers in a rain screen system, did it? I.e. where the wall in front of the barrier is not concrete or blockwork, but for example, a metal or terracotta panel.
No, it does not, because the test standard is to confirm the performance of the cavity barrier in isolation from any other construction elements. It's the responsibility of the fire engineer on the project to take the test data from all other products to come up with the overall fire performance. And that's applicable to any passive fire protection, not just cavity barriers.
Yes, thank you. Now, returning to Mr. Swales's witness statement, paragraph 50, page 13, that's SIL 50306, page 13. So when discussing this draft standard, we looked at this part earlier. He says that it was tested to the temperature and pressure conditions of BSEN 1363 part 1. Can you just explain to us precisely how that testing used the temperature and pressure conditions of that European standard?
Okay. BS 476 part 20 and BSEN 1363 part 1, both those documents utilize what they call the cellulosic time temperature curve. When you're dealing with fire testing, there's three major time temperature curves. There's a slow burn time temperature curve, which maxes out at around 650 degrees. Then there's a cellulosic time temperature curve, and then you have the hydrocarbon temperature curve, which is extreme for oil refineries, oil rigs, etc. So the cellulosic curve also is known as the ISO 834 time temperature curve. So both BS 476 part 20 and EN 1363 part 1 use ISO 834 time temperature curve.
Yes.
That's a logarithmic equation. It can be looked up in any of the standards, but it's basically temperature is equal to a log of time plus temperature rise, and it plots out and controls the furnace in the graph. In terms of pressure conditions, both 476 regimes in all guises for fire resistance test and EN 1363 part 1, you have to establish a 20 pascals plus or minus 3 pascals, 100 millimeters below the seal that is being tested. Now that gives you a positive pressure on the furnace.
I understand. So I think what you're saying is you've used the time pressure curve from that European standard in this test, yes?
Yes.
But only once the seal has activated?
No, the time temperature curve is used from time 0.
Right, I see.
As soon as the furnace is turned on, the time temperature curve is worked.
Yes. And then the pressure requirement, the positive pressure on the furnace that you were explaining,
yeah,
is that used throughout or just for part of the test?
No, in EN standards and in BS standards, in the first 5 minutes of any test, the laboratory has to establish temperature control to the curve within agreed tolerances and pressure control within agreed tolerances. Now, in the first 5 minutes, they have to get 20 pascals plus or minus 5. Then after the 5 minutes, it drops to 20 pascals plus or minus 3. So that is measured from time 0.
Right, I see. So it's using the temperature curve requirements and the pressure standards from that European standard.
Yes.
Yes. And then Mr. Swales goes on and he says, so he's explaining that was a draft standard, and we saw some testing to that just now. And then he says this, picking it up in the 4th line, I confirm for the avoidance of doubt that although it is called a draft standard, there are very few differences to the actual test to what was later termed TGD 19. The only significant difference is to the standard thermocouple arrangements. Now, can you just explain what that means? What were the differences in the final standard on thermocouple arrangements?
Okay. In the draft, there were suspended thermocouples above the air gap, nominally at centre of seal and at a third either side. On the cavity barrier itself, there would be similar thermocouples affixed to the top surface of that, and where you got a joint in the seal, there'd be a thermocouple affixed adjacent to the joint to measure the performance of the joint. In the very early draft, from memory, we didn't have any further thermocouples on the insulation above the cavity barrier. However, on our test, and it went forward with the final draft of TG19, where you're using thermal insulation above and below a cavity barrier, the thermal insulation directly above the cavity barrier also had thermocouples affixed to it.
I see.
To measure the performance of that, so that if at any point the cavity barrier started to break down where it butted the concrete on the back wall, so not where the intumescent is, on the opposite end of the seal, there could have been a potential route for fire to pass up the back of it. So by having the thermocouple on the insulation, you could measure that also. And it's
I see. So I think you're saying the final test standard had an additional location for thermocouples. You'd already got a thermocouple in the gap, and you've explained what happens about how you treat the temperature that thermocouple detects. You've got a thermocouple on top of the barrier on the unexposed side. And then the final version of the test also included a thermocouple in the insulation itself.
In reality, you would have somewhere just on the specimen itself, so we took in insulation, cavity barrier, air gap, around 10 thermocouples.
Right.
You would also have thermocouples on the concrete, measuring the performance of the concrete as well.
Yes. Now, can we turn to another test report? This is a Chiltern International BM Trada report. This is at SIL 50288. This is from the 24th of April, 2014. So we can see from the top in the green box, this is written by Chiltern International Fire Limited. It's dated, we can see from the test date towards the bottom of that writing that it's the 24th of April 2014, and it's called a fire resistance test performed 3 horizontal ventilated cavity fire barrier seals within a concrete supporting construction.
Yes. And
we can see that the test below that, it says test conducted in accordance with the test standard ASFP open state cavity barrier used in the external envelope or fabric of buildings and utilizing the principles of BSEN 1363 part 1 2012. So just for clarity, was that the TDD 19 test?
Yes, it was.
Yeah. And then if we turn to page 4, we can see under the description in section 3, yes, at the bottom there, description of supporting construction. It says there, the supporting construction comprised 150mm thick, lightweight, aerated, reinforced slabs built on top of a 1,500mm squared furnace. So, and then it says the exposed area of the supporting construction included 3 apertures, 300mm wide by 600mm deep by 1,300mm long, exposed to the fire to accept the cavity fire barrier seals. So again, a familiar construction in terms of the test apparatus, yes?
Yes, it's a standard construction offered by all test labs right across the world.
Yes, and the barriers are being tested between aerated reinforced concrete slabs, yes?
Yes.
And they were constructed to provide 300mm wide voids into which the barriers were placed, yes?
Yes.
And then if we go to page 5, under section 4.1, at the bottom of that page, we can see that cavity barrier A, we only need to look at the end of this, we don't need all the detail. That had a free air gap of the cavity 50mm wide, yes? And you see the very final sentence, the free air gap of the cavity was 50mm wide.
Yes.
Yes. And we can see page 6, cavity barrier B. We can see at the end of the text on cavity barrier B that had a free air gap of the cavity of 44mm wide. And then at page 7, we can see that cavity barrier C also had an air gap of 50mm wide.
Yes.
Is that correct?
Yes.
So in April 2014, Siderise were testing its cavity barriers to this standard with air gaps of up to 50mm, yes?
Yes.
And then if we go to page 18, this is where we get a section called expression of results. And then if we go to the first paragraph of that, it says technical failure of the integrity and insulation would deem to have occurred at the start of the test due to the open void required for such seal types. However, following the rapid expansion of the intermescent layer, the gap becomes fully sealed and the product achieved the integrity stated below. And then it goes on, due to the nature of ventilated open state cavity barrier seals, an initial spike in temperature is recorded by the thermocouples positioned in the air gap adjacent to the seal as it is open to the furnace. The temperature is rapidly reduced once the seals react and fill the whole cavity. The air gap insulation figure quoted in the results disregards this initial spike in temperature, provided the temperature returns to below 180 degrees C rise within the first 5 minutes of the test. Do you see that? So,
yes.
So that is quite a good description, isn't it, of how this test is attempting to take temperature readings given the initial spike in temperature that's experienced, yes?
Yes, and also this test, as in the previous pages, you will see it has PIR combustible insulation above and below the seals. So that in the first 5, well, at any point during the test, should the combustible insulation above the cavity barrier catch fire or increase its temperature above the 180, then it's a fail. So it also measures that element.
Yes, I understand. And in the table then, we can see the results for integrity and insulation. Just focusing on the right for the moment, on the insulation, it says insulation fixed thermocouples and then air gap insulation suspended thermocouples. Can you just help us as to why we're seeing different figures there?
Okay, this has been clarified further in TGG 19. The air gap insulation suspended thermocouples are only there to measure the closure of the intumescent. Intumescent by its nature expands, and it expands multi-directional. So these thermocouples are suspended above the cavity. When during the test the intumescent continues to expand and can engulf the thermocouples.
Right.
So
in terms of what we're looking at, the insulation figure that you would take and you would take forward from this, are we looking at the one in the left hand column or the right hand column?
The fixed thermocouples.
Yeah. So barrier A would have 39 minutes insulation, B 46 and C 53, yes?
That's correct.
I see. So on the right, we're just seeing some extra measurements that are taken through that air gap insulation process.
Exactly that, and they're there to assist the assessment by further fire engineers or project consultants on suitability of products.
And then on the left, we've got integrity. We can see in the middle, gap gauge is not applicable. That's the poker stick, which previously would have given a fail. So that's held not applicable. And then we've got cotton pad and continuous flaming. Again, can you help us? Which is the integrity figure that you would use based on this test?
The lesser figure of either.
Right, I see. So if either a cotton pad were ignited or there was continuous flaming, whichever happens first, that's your integrity figure, yes?
Yes.
I see, yes. And then underneath that table, we can see, we get some helpful data about the time that was taken for the ventilated cavity to be sealed, yes?
Yes.
So we can see for the first asterisk, it's referring to cavity barrier A. It was sealed at 2 minutes, 22 seconds. Cavity barrier B, it says the failure criteria was not achieved upon termination of the test at 62 minutes, yes?
Yes.
And then we've got a hash symbol for continuous flaming for cavity barrier B. It says failure after the ventilated cavity was sealed at 1 minute 44 seconds. So what's that telling us?
It's basically, if you look at cavity A was a 50 millimeter gap. It closed in 2 minutes 22 seconds. In cavity B is a 44 millimeter gap. So by reducing it by 6 millimeters, you're increasing the performance of the rapidness for to seal.
And cavity barrier C was also a 50 millimeter cavity, wasn't it? And that's sealed at 3 minutes 19 seconds. Yes. Yeah.
And again, these are R&D tests to establish product development.
Yes. Mr. Chairman, I think that's probably an appropriate moment. I'm still kind of midway through this topic, but I'm about to refer to some other testing. So,
well, if that suits you, we'll stop there.
Yes, it does. Thank you.
Right. All right. Now, Mr. Mort, we're going to have a break now so we can all get some lunch.
Yes.
We'll come back at 2 o'clock, please. And again, I have to remind you, please not to talk to anyone about your evidence or anything to do with it over the break. All right.
Understood.
Thank you very much. See you at 2 o'clock then.
Thank you.
Thank you.